talking to you. I am really good at talking in third person, aren't I? All right. Hide. All right, here we go. Determine the formula for the table at the right. We know that the formula for an exponential function is f of x equals ab to the x power. A is called the what? Initial value. What's our initial value here? 5/4 is what when x is 0. This is your initial value. How do you get from 5/4 up to 5/16 or down to 5/16 in this case? Multiply by 1/4, right? If we multiply by 1/4, we get there. Because 20 times 1/4 gets there, 5 times 1/4 gets there. So B, what we're multiplying each time is by 1/4. And this is our equation. Okay? Are we good with that? Okay. And it says, solve this equation graphically. 8 to the x power, 4 to the x power. 8 to the first power is 1/8. 4 to the first power is 1/4. Okay? Where is 8 less than 4? Well, it's not where it's greater than 0, so it must be where it's less than 0. Now, if we think about it, -1, 8 to the -1 power is 8 to the -1 power is 1/8. 4 to the -1 power is 1/4. What's bigger? 1/4 is bigger than 1/8. So 1/8 is less than 1/4 when x is less than 0. Okay? We solved it graphically. We solved it numerically. Here we go. Okay. Now, this one's kind of dumb because you don't need any of this right here. We're just worried about city A. Okay? Using the mid-year data in the table, when did city A surpass 700,000 people? Okay? The year which they reached 700,000 people. So, if this is exponential, okay, in 1990, they were, so the x value is that, the y value is this. Okay, so we're assuming that the growth is exponential. So basically, this is year 0, and so this would be the year 21. Okay? So we want to know when it will surpass that. So if this is 0, f of x equals 464,732 b to the x power. So now we fill in these. So we fill in 820,083 equals 464,732 times b to the 21 power. So we figure out what b is. Okay, so we'll divide by 464, 732. So b to the 21st equals what? It should be 1.9 something, I would bet, right? Oh, I don't have my graphing calculator on this one. So, 1 point what? 7646? Nah, that's probably good enough. Now, to get rid of the 21st power, we take each side to the 1 over 21 power. What does b equal? 1.7646 to the 1 over 21 power. Give me about 5 decimal places. 1.41. Okay, that's what b is. So now we got to see when the population is 700,000. So 700,000 equals 464,732 times 1.02741 to the x power. So take 700,000 divided by 464,732. What do we get? What's 700,000 divided by 464,732? 1.50624 equals 1.02741 to the x power. If we take the log of both sides, the x can come up front, and then I'll divide by the log of 1.02741. So the log of 1.50624 divided by the log of 1.02741, what does x equal? Hopefully it's less than 20. What is it? 15 point what? 48. So 15.48 years after 1990. So 2005.48. Hopefully it's 2005. Maybe it's 2006. Let's see what it is. 2005. So we were right. Okay? So that one it took a little bit to do. McKenna, you need to see it again. So we started. Oh, I hate when that happens. So, because 1990 is year 0. So 1990 plus 15 is year 2005. Okay, this next one hopefully will be a little bit better. Okay, the next one, the bacteria one. Okay. What's the initial amount of bacteria present here? 900. It says right in the problem. It's your initial value. How much bacteria will be present after 5 hours? You just put a 5 in here, so you take 900 times e to the 0.0 or 0.693 times 5. So take 0.693 times 5, e that number, take that times 900. Round it to the whole number. How much bacteria is present? 20,779. Yep, you are so right. Okay. Determine the exponential function that satisfies the given conditions if the initial value is 17 and it's decreasing at a rate of 40% per year. Well, if it's decreasing at a rate of 40% a year, you take 1 minus 0.4, which is 0.6. So P sub t will equal 17 times 0.6 raised to the t power, where t represents time. Half-life. Half-life of a certain organism is 14 days, or 2.5 grams initially. Express the amount in terms of time. So, the function is, at the start, there's the initial value of 2.5. It's a half-life, so half of it will remain in the amount of time divided by 14 days, because it takes 14 days for it to get half of itself. So in 14 days, it'll be half of itself. So 14 over 14 is 1. Okay? So that's half-life. Half to the power, or the time power, over the number of days it takes to have a half. There will be 1 gram remaining after how many days? So to figure that out, we set 1 equal to 2.5 times 1/2 to the t over 14 power. So before we log each side, what do we have to do? In this problem, before we log each side, what should we do? Divide by 2.5. 1 divided by 2.5, I think, is 0.04, or 0.4, but I'm not sure. Now you have a number on the right-hand side of the equation to a variable power. The only way to get that variable power down is to log each side. So we say the log of 0.4 equals t over 14 times the log of 1/2. So we're going to multiply each side by 14 to get rid of the 14, and we're going to divide by the log of 1/2. So you take 14 times the log of 0.4 divided by the log of 1/2. Fourteen times the log of 0.4 divided by the log of 1/2. What do we get? Yep, 18.507. Because it says round to the nearest thousandth. Okay, now we're to the easy stuff for the next 6 problems. 6 to the x equals 36. So what does x have to be? 2. So the log base 6 of 36 is 2. Did you know your graphing calculators do logs with bases and all that? Or you could use this change of base formula, log of 36 divided by log of 6. That would also work. If you take log of 36 divided by log of 6, what do you get? Should get 2. Okay. This one, natural log of this, I would rewrite as the natural log of e to the 7/9 power. Because the 9th root of e to the 7 is e to the 7/9 power. Well, what do ln and these do? Cancel each other, so you get 7/9. E and ln's cancel each other, so this next one is simply 12. What's the base of a log? 10. So this is a log base 10 of x equals 2. So x equals 10 to the 2nd power. So that's what you'd write here. You wouldn't have the x equals, I suppose. It would just be 10 squared. And 10 squared is 100. What's the common log of 21? The log base 10 of 21. Well, you can just use your calculator. 10 to the what power equals 21? I would say 10 to the 1.3222, right? If I was guessing. The log of 24 over 10 expressed as a difference of logarithms. Difference means a what kind of problem? Add, subtract, multiply, or divide. Subtraction. This is the log of 24 minus the log of x. The log of 24 minus the log of x. Okay? Write these as a single log. When you have numbers in front, where do they go? As exponents, as powers. So it's the ln, I'll write that better. It's the ln of x to the 4th plus the ln of z to the 5th. And then with addition, we can combine them to be one log. So it's the ln of x to the 4th times z to the 5th. That's written as a single logarithm. Change of base formula is the log of the big number divided by the log of the little number. Log of 70 divided by the log of 6. And then you write that there, and then you divide, and what do we get here? What do we get? Log of 70 divided by log of 6. Because 6 to the, no, it's bigger than that. 2.371. Because 6 to the 2nd power is 36. 6 to the 3rd power is 216, so it has to be somewhere between 2 and 3. On this one, see how there's a 5 in front? So what should we do as a first step? Divide by 5. So 5 to the x over 2 power equals 3125 divided by 5 is 625, correct? Now, we can use our calculator now. I wouldn't have to, but we can. Okay? Using your calculator, take the log of both sides. So x over 2 log of 5 equals log of 625. So if we multiply by 2 and divide by the log of 5, if you take 2 times the log of 625, press equals, divide by the log of 5, what do we get? Should be a whole number. 8? Sounds right. because the log of 625 is, the log of 625 is basically 5 to the 4th power. So 5 to the x over 2 equals 5 to the 4th. We can drop the 5's on each side. X over 2 equals 4. So x equals 8. We can do it that way too. Solving this equation, what do we do to each side first? We take the log of both sides. So x equals log of 4.3 divided by the log of 1.15. Log of 4.3 divided by the log of 1.15. What do we get? Decent sized number, not super small. $10.436. There it is, 10.436. All right. Find the amount accumulated after investing P principal for 10 T years with the rate compounded continuously. Now, for some reason, did I have any continuously problems on your homework? Or did I have a hiccup and not put any continuous? Continuous is the amount equals the principal times e to the RT. Did we have any of those problems? We should have. I screwed it up somehow, and we didn't. So when you see compounded continuously, you don't put some huge, gigantic number in. You use e. Okay? So the amount in the end equals the 29,000 times e to the, and then you do not, e to the 0.033 times 10. So it's 29,000 e to the 0.33, in other words. So if you do that, how much will you get? And I would say it's 40-some thousand. 40,338.08. 4338.08. We get that? Okay. Oh, doubling time. Now I'm going to teach it right today because I sure didn't teach it right yesterday. So, you want it to double. So, whatever your principal is that you start with, you want it to double. So, you're going to have 2p here. And if it's quarterly, it's compound interest. So 1 plus the rate divided by the number of times it's compounded per year to the number of times it's compounded per year to the time power. So 2p equals p times 1 plus 0.068 divided by 4 to the 4t power. If we divide both sides by p, the p's cancel, so it's just 2 equals 1 plus, well, let's figure that out. What's 0.068 divided by 4? To the 4t power. So if we log both sides, that 4t comes out front. So to get t alone, we divide by 4 log 1.017. Make sure you put that 4 in parentheses. If you take log of 2 divided by 4 times this, without using parentheses, it'll take log of 2 divided by 4, and then it'll take that answer times the log. You're really dividing log of 2 by both these numbers. What did you get for an answer? Log of 2 divided by parentheses 4 log of 1.1017. So it's 10 years, and then you take the 0.28 times 12. 0.28 times 12 is just less than 3, right? Ooh. Because the answer key said 10 years and 3 months. But it should, if it's over 3, then it should be 10 years and 6 months. But yeah. So maybe rounding was off just a little bit. But the answer, according to them, is 10 years, 3 months. Okay. All right. 19. After how many years required for an investment to double after its appreciating interest at 13% compounded continuously? Again, one more time, the compounded continuously is PE to the RT. So if you want it to double, you get 2P equals PE to the RT. So what should we do first? Divide by P. So 2 equals E to the 13T. How do we get rid of an E on both sides? You natural log it. So the ln of 2 equals 13T. So then you just divide by 13. What's the ln of 2 divided by 13? That seems awful short. 5.33. Oh, it's 0.13T. Divide by 0.13. I was going, what? So it's 5.33 years. 5.33 what? $5.332. Okay, last one. What's total value after 6 years of an investment like this that earns that much interest compounded quarterly? So if it's compounded quarterly, that's the amount equals the principal to the 1 plus the rate divided by the number of times compounded to the KT power. So it's 1,750. That earns 1 plus 0.047 divided by 4 to the 4 times 6 power. And just put that in your calculator.